Two or more coordination compounds having same molecular formula but different physical and chemical properties are called as isomers, and the phenomenon is called as isomerism. Geometrical isomerism is not possible in coordination compounds having coordination number 4, that is in case of tetrahedral geometry. It is only possible in square planar complex. Ionization isomerism. This isomerism arises when two or more compounds having same molecular formula but they produces different ions when they dissolve in water and when they undergo ionization. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to third session of chapter Coordination Compound. Third session of chapter Coordination Compound. In the previous session, I discussed about coordination sphere, ionic sphere and how to name a coordination compound according to IUPAC nomenclature, as well as classification of ligands like monodentate ligands, bidentate ligands, polydentate ligands and ambidentate ligands. My dear student, this session I am going to deal with a topic isomerism in coordination compounds. Under that, you already know that two types of isomerism, structural isomerism and stereoisomerism. Structural isomerism and stereoisomerism. When you consider isomerism, what's the definition for isomerism? Two or more coordination compounds having same molecular formula but different physical and chemical properties are called as isomers, and the phenomenon is called as isomerism. This isomerism is broadly classified into two types, structural isomerism and stereoisomerism. In structural isomerism, we have four types: linkage isomerism, coordination isomerism, ionization isomerism, solvate isomerism. What are the four types of isomerism which comes under structural isomerism? Under structural isomerism, we have four types of isomerism: ionization isomerism, linkage isomerism, hydrate isomerism, coordinate isomerism. Under stereoisomerism, we have two types: geometrical isomerism and optical isomerism. Geometrical isomerism and optical isomerism. Isomers are two or more compounds that have same chemical formula but different arrangement of atom. Because of different arrangement of atom, they differ in one or more physical or chemical properties. Already I explained that isomers having same molecular formula but they differ with respect to physical and chemical properties. The phenomenon is called as isomerism. In stereoisomerism, they have same molecular formula and same structural formula, but they differ with respect to the spatial arrangement. They differ with respect to the spatial arrangement. Such isomers are called as stereoisomers, and the phenomenon is called as stereoisomerism. Under stereoisomerism, we have two types: geometrical isomerism and optical isomerism. Geometrical isomerism and optical isomerism. Under structural isomerism, we have four types: linkage isomerism, coordination isomerism, ionization isomerism and solvate isomerism. First, let us consider geometrical isomerism. It's a phenomenon in which two complex compounds have the same molecular formula, same structural formula, but different geometrical arrangement of the ligand. The two forms are called cis and trans. What are the two forms of geometrical isomer? Cis and trans. If the ligands are attached to the central metal atom or ion which lies on the same side, it is called as cis isomer. If the ligands are present opposite side of the central metal atom, is called as what? Trans isomer. That's why geometrical isomerism is also called as cis-trans isomerism. It is also called as cis-trans isomerism. Cis-trans isomerism. Let us consider geometrical isomerism of coordination compounds having coordination number 4 and coordination number 6. When you consider coordination number 4, we have two geometries. One is tetrahedral and square planar. So, geometrical isomerism is not possible in coordination compounds having coordination number 4, that is in case of tetrahedral geometry. It is only possible in square planar complex. So, let us consider complex with formula MX2L2, where X and L are unidentate ligand, exhibits isomerism, cis isomerism and trans isomerism. For example, Platinum attached with 2 amine ligands and 2 chlorido ligand, PTNA3 twice and Cl2. Observe here, 2 chlorine ligands are lies on the same side of this, it is attached to the central metal. Here it is present opposite to each other. Therefore, it is known as cis and what? Trans. Let us consider, my dear student, when the coordination number 4, what are the possible geometry? Tetrahedral and square planar, and the geometrical isomerism is not possible with tetrahedral complexes. It is only possible by square planar complexes. Let us consider octahedral complex. Octahedral complex, we have type MX2L2, where X and L are unidentate ligands. Cobalt, Na3,4Cl2. Observe here, cobalt is attached with 4 amine ligands and 2 chlorido. Here also 4 amine and 2 chloride. Here chlorine atom present adjacent to each other. Here chlorine atoms are present opposite to each other. Therefore, it is cis and it is known as trans. When you consider second type of coordination complex, MX2LL2, X is unidentate, LL is bidentate. So, example, ethylene diamine, NH2CH2CH2CH2, it is a EN, ethylene diamine. Geometrical isomerism of COCl2 EN twice, it is attached with 2 chlorido as well as 2 ethylene diamine. Observe here chlorine atoms are adjacent to each other and here chlorine atoms are opposite to each other. Therefore, it is known as what? Cis, and it is known as what? Trans. As well as ethylene diamine is a 2 donor atom. You have to write the structure like this ring structure, 2 donor atom. That means it forms 2 coordinated bonds with central metal atom or ion. Okay. Next, octahedral complexes with general formula Ma3B3, where A and B are monodentate ligand. Here we have 2 types of isomer, facial isomer and meridional isomer. Facial is FAC isomer and MER isomer. Take CO is attached with 3 amine ligands and 3 NO2 ligand. Here 3 NO2 ligands are present at the corners of the octahedral face. Corners of the octahedral face. Therefore, it is facial or FAC isomer. So, here 3 isomers are present. Donor atoms are around the meridian of the octahedron. Meridian of the octahedron. They present it in what? Meridian of the octahedron. Therefore, it is called as meridional isomer or MER isomer or MER isomer. Next, move on to optical isomerism. When 2 are coordination compounds having same molecular formula, but they differ with respect to the rotation of plane polarized light. So, one compound rotates plane polarized light to the right, other one rotates to the left. Therefore, levorotatory and dextrorotatory. To the left, levorotatory, to the right, dextrorotatory. As well as the 2 isomers are there non-superimposable on their mirror image. They are called as enantiomers. Now, it's an example. Cobalt is attached with 3 En ligand. Here also cobalt is attached with 3 En. When you keep mirror, they are non-superimposable mirror images. Therefore, they are called as stereoisomer. It rotates to the right and it rotates to the left. Therefore, it is called as dextro and it is called as what? Levo. So, this is about optical isomerism. Therefore, my dear student, under geometrical isomerism, I discussed about 2 types of isomerism, geometrical isomerism as well as optical isomerism. In geometrical isomerism, we have 2 types, cis isomer and trans isomer. In optical isomerism also, we have 2 types, dextrorotatory and levorotatory. Next, structural isomer, first one, linkage isomerism. Linkage isomerism, 2 or more compounds having same molecular formula, but they link to the central metal atom with 2 different donor atom. Therefore, it is only shown by ambidentate ligand. Observe here cobalt is coordinate through nitrogen. Here cobalt is coordinate through oxygen. That is, first one it is nitrito N. Second one it is nitrito O. Therefore, the linkage isomerism is type of isomerism in which 2 complex compounds differ in the donor atoms of ligand. Different ligating atom. It is shown by complex compounds containing ambidentate ligand. Example, pentaamine nitrito N, cobalt 3 chloride, pentaamine nitrito O, cobalt 3 chloride, and here also pentaamine thiocyanate S cobalt 3 chloride, pentaamine thiocyanate N cobalt 3 chloride. Here it is coordinate through sulfur, here it is coordinate through nitrogen. Here ambidentate ligand are NO2 minus and SCN minus. Sometime it is ligate through nitrogen and sometime it is ligate through oxygen. Here sometime it ligates through sulfur and sometime it ligates through nitrogen. Next to coordination isomerism. This isomerism arises due to the exchange of ligands between cationic entity and anionic entity. Here in cationic entity was the ligand present amine, in anionic entity the ligand present is cyanido. Please exchange this. Here it will become chromium hexa amine chromium, it is hexa cyanido cobalt. Therefore coordinate isomerism arises because of the exchange of ligands between cationic entity as well as what? Anionic entity. Third type of isomerism is ionization isomerism. This isomerism arises when two or more compounds having same molecular formula but they produces different ions when they dissolve in water and when they undergo ionization. Any coordination compound when it is dissolved in water, it undergo ionization. During ionization, they produces different ion, that is known as ionization isomerism. For example, I will consider pentaamine chlorido cobalt 3 sulfate, pentaamine sulfato cobalt 3 chloride. Here during ionization we will get sulfate ion as a counter ion. Here you will get a chloride ion as a counter ion. Last one, solvate isomerism. Two or more complex compounds having same molecular formula but they differ with respect to number of water molecule act as ligands as well as water of hydration. Observe here 6 aqua act as ligand, here 5 aqua, but here water of hydration 0, but here it has water of hydration 1. What's the color when there is no water? Violet. It is grey, green, grey, green. Therefore, so in this third session, I explained about isomerism of coordination compounds, like two types of isomerism, structural isomerism and stereoisomerism. Under structural isomerism, I discussed about 4 types of isomerism like ionization isomerism, linkage isomerism, hydrate isomerism and coordinate isomerism. Under stereoisomerism, I discussed about 2 types of isomerism, optical isomerism and geometrical isomerism. Therefore, in the next session, I will come up with the theory about coordination compound, that is Werner's theory. Therefore, next session, I will come up with theories of coordination compound. Until that, goodbye. Take care. Thank you.